We're given a rational function, and we're first asked to find the domain of the rational function and then use several steps in order to graph the rational function. So we have f of x equals x over x squared minus 16. So first, let's talk about the domain. In order to find the domain, let's set the denominator equal to 0. When we solve this, we get x squared equals 16. By taking the square root of both sides, we get x is equal to plus or minus 4. So these are the two values that will make the denominator 0, so we need to exclude them from the domain. So our domain is the set of all x such that x is not equal to positive or negative 4. Now, let's move on to step 1. Step 1, we want to first determine if we have any symmetry in this rational function. In order to find symmetry, we look at f of negative x. So we have negative x over negative x quantity squared minus 16. This simplifies to negative x in the numerator over x squared minus 16. Now, notice that f of negative x is exactly the opposite of our original function f of x. We know it's the opposite because the numerator is exactly the opposite and the denominator is the same. So therefore, we can say that this is an odd function, and that will help us in our graphing. We know an odd function is symmetric with respect to the origin. So that simply means if we have a point, say in the first quadrant, x comma y, we'll also have a point in the third quadrant, negative x comma negative y. So let's go ahead and move on to step 2. And let's find any y-intercept if it exists. We find the y-intercept by letting x equal 0. So we're really finding f of 0, and that's equal to 0 over 0 squared minus 16, which is just 0. So our y-intercept is 0. So in step 3, we want to find any x-intercepts. Now, anytime we have a y-intercept of 0, clearly the x-intercept is 0 as well, but there may be additional x-intercepts. So let's see if there are any additional x-intercepts. We find the x-intercept by letting y equal 0. So we have 0 equals, and then we just set our numerator equal to 0. X. Well, x equals 0 is the only x-intercept. Now we move on to step 4. Step 4, we want to find any vertical asymptotes that we have. We find vertical asymptotes by setting the denominator equal to 0. Well, we already set the denominator equal to 0 when we were looking for our domain, and we got a solution that x was equal to positive or negative 4. So we do have 2 vertical asymptotes. In step 5, we look to see if we have a horizontal asymptote. In order to determine if we have a horizontal asymptote, we want to compare the degree of the numerator with the degree of the denominator. In this case, the degree of the numerator is 1. We have x to the first power. The degree of the denominator is 2. We have x to the second power. Anytime the degree of the numerator is less than the degree of the denominator, we have the horizontal asymptote, which is the line y equals 0, which is just the x-axis. So now in step 6, we're going to plot a few points. But before we do that, I want to use the information I already have to help us pick those points wisely. So we've already plotted both our x and our y-intercept. Let's plot our vertical asymptotes now. We have that x can be positive 4, so we want a line going through 4, a vertical line that is, going through 4 on the x-axis, and another vertical asymptote passing through negative 4 on the x-axis. And then I have a horizontal asymptote, y equals 0, so I'll just extend the x-axis with a dotted line. Now we're ready to pick a few points. Normally, I pick points between any vertical asymptote and any x-intercept, but really I only need to pick half as many points here because I have symmetry. So I'm going to start off just to the right of the y-axis, and I'm going to choose a value in between 0 and 4 for x. So let's pick, say, 2. If I let x equal 2 and substitute it into my original function, I'll have 2 over 2 squared, which is 4, minus 16. So that gives me 2 over negative 12, or 1 over negative 6. So negative 1/6. Let's choose one more value to the right of 4. Let's let x equal, say, 5. If we let x equal 5, I'll have 5 over 25 minus 16, which just gives me 5/9. Now, let's plot these 2 points, and then we'll use symmetry to plot 2 more points. So we have the point 2, comma, negative 1/6. And we also have the point 5, comma, 5/9. Right about here. So we're also going to have another couple of points. Since 2, negative 1/6 was on the graph, we're also going to have negative 2, positive 1/6. In other words, we just take the opposite of the x and y value. So we have negative 2, positive 1/6. And then finally, since 5, comma, 5/9 was on the graph, we'll have negative 5, comma, negative 5/9. And that's over here, right about here on the graph. Now, we'll use these points and the asymptotes to sketch our graph. Since we know that the curve will always tend toward the asymptotes, we can sketch it in like this. And this is a sketch of f of x.